As you've already realized, standard normal distribution or normal distribution has very interesting properties. Therefore, sometimes it is really nice to have a variable that is normally distributed, and most of the time you won't have the information directly whether it is normally distributed or not. You will need to assess the data to see if it is normally distributed or not. To do that, you can use the following three methods. The first method involves constructing a histogram of the data and noting the shape of the graph. So if the data that you've got are approximately normal, the shape of the histogram that you make will be similar to a normal curve. The display will be bell-shaped and symmetric about the mean. And here is an example for you. So as you can see, the mean value is more or less in the middle, whereas the values are symmetric around it, and when we draw a line we more or less get a bell-shaped line, which is probably an indicator of normal distribution. The second method involves computing the intervals, so the mean value plus minus standard deviation, the mean value plus minus 2 standard deviations, and the mean value plus minus 3 standard deviations. And after you've constructed those intervals, you need to determine the percentage, so the proportion of values falling into each of these interval. And if the data that you've got are approximately normal, the percentages that you calculate in the second step will be approximately equal to 68%, 95%, and 10%. So 68% of your observations will fall within the interval of mean value plus minus standard deviation. 95% of your observations or your values will fall within the interval of the mean value plus minus 2 standard deviations, and 100% of your observations, so all your values, will fall between the interval of mean value plus minus 3 standard deviations. And the third method involves calculating the interquartile range and standard deviation, and then calculating their ratio. And once again, if the data that you've got are approximately normal, then you will get the ratio more or less equal to 1/3. So to calculate this, once again, you take the upper boundary, so the highest value out of your data set, subtract the lowest value out of your data set, and divide by standard deviation.